Okay, so on Friday, we learned about long division. Okay? Today, we're going to learn something called synthetic division. When you hear the word synthetic, what do you think of? Fake. Okay? So, this is a fake or contrived process that helps us as a shortcut of long division. Okay? It doesn't work all the time. Okay? You can't use synthetic division all the time. You can only use synthetic division when you have what we call a linear factor. And what I mean by that is you can only try and use synthetic division when you're trying to divide by x minus a number or x plus a number. If you had 2x plus 1, trying to divide by that, you could not use synthetic division. If you had an x squared, you couldn't divide by that using synthetic division. So, synthetic division, like we said, is a fake process to help us as a shortcut for long division. It's basically what's called an algorithm. And what an algorithm means, okay, is a process, a set of steps to get you to your answer. Okay? Some of you are going to ask, why does this work in your head? How does it happen? Why does it happen? I don't know. I didn't make it up. Okay? It's one of those things that's going to look really weird at the beginning, but you'll start to really like it as we work our way through. Okay? But the why isn't going to click in your head because it's very fake. It's contrived. It's just made up to get you to the answer. Okay? All right. Yes?
Does it give us some, like, an exact answer of what the other, like, that would give us long division?
Okay, so we are going to start off with number 2 from Friday, okay? Number 2 in our notes from Friday. That's going to be the first one we start off with, okay? X to the 4th minus 10x squared plus 2x plus 3 divided by x minus 3, okay? Why am I allowed to use synthetic division here? What am I dividing by? Yeah, I'm dividing by x minus 3, this thing right here. Okay? And x minus 3 is a linear factor, so I'm allowed to use synthetic division. Okay. Now, the setup, like I said, it's all going to look weird. Just kind of go with me. Okay? So, let me show you how we set this up. All right. If x minus 3, if I am checking to see that x minus 3 is a factor of this, then what am I checking to see is a root? 3. Okay? X minus 3 is the factor. So I'm checking to see if x minus 3 equals 0, then x would equal 3. I'm checking to see if x equals 3 is a root. Okay? So you're going to use that number 3. You're going to write that down. Let me show you how to do that. Okay? And draw this like long L looking thing. Leave yourself like 2 lines with the L going down. Yeah. Okay? On the top row, we are going to list the coefficients of what we're starting with. Okay? And like Corey said, notice on this one we're missing x cubed, right? So we're going to have to put a placeholder. So my coefficient of x to the 4th is what? 1. Then I've got, what do you think I'm going to write next? 0. Good, because I'm missing x cubed. So write yourself as 0. Then negative 10, 2, and 3. So the first step is you write out the coefficients, making sure you put any placeholders where it's not represented. Okay, this is the setup. Now let's actually work through the process. Here's what we're going to do. Okay, first thing we're going to do is we are going to bring down the first term. And we're going to write it down. So your first step is to bring down. All right? Then we're going to multiply. And we are going to multiply 1 by 3. What is 1 times 3? 3. So I'm going to write 3 right here. After I multiply, I'm going to add. 0 plus 3, 3. Okay, and I'm just going to keep repeating these two. Okay, so now we multiply again. 3 times 3 is 9, so I write my 9 in right here. Negative 10 plus 9, negative 1. Negative 1 times 3, negative 3. 2 plus negative 3, negative 1. Negative 1 times 3, negative 3. 3 plus negative 3, 0. Okay, so let's talk about what this in fact means. Okay? That 0 right here, this 0, that's your remainder. The last number you get, the last number in synthetic division, that's your remainder. Tell me what a remainder of 0 tells us. What's a factor? X minus 3 is a factor. Good. So what else does that mean? Not a factor. 3 is a root. 3 is a root. A number is a root. Something with x in it is a factor. Good. So 3 would also be, since it's a real root, would that also be an x-intercept? Yeah. What would f of 3 equal? 0. Because remember our remainder theorem. Whatever you get when you divide by that factor is what you would get if you plugged in the root. So f of 3 is 0. Okay, but we don't have an answer yet, though, right? So this is your remainder, and then you're going to work kind of your way backwards to figure out which terms are which. Okay? This term right to the left of your remainder is your constant. Then you have your x term, your x squared term, and your x cubed term. So I would go ahead and write my answer as x cubed plus 3x squared minus x minus 1. If you look back in your notes, you'll see that that's what we got when we used long division. We got x cubed plus 3x squared minus x minus 1. Questions? Want to see it again? Let's try it again. Okay? This one's number 3 from Friday. This is the last one we did from Friday. 3x cubed plus 8x squared plus 5x minus 7 divided by x plus 2. All right, try the setup. Try and put everything where it goes in your original setup. Does yours look like this? You have negative 2 outside. Oh, yes, thank you. This should be negative 7, sorry. Okay? Remember that it's negative 2 because if x plus 2 is a factor, what would x equal for your root? Negative 2, because you think about taking x plus 2 and setting it equal to 0. Okay? All right, what do I do first? Bring down, so bring down our 3. I'm going to write down the 3. Then what do I do? Multiply. 3 times negative 2? Negative 6. 8 minus 6? 2. 2 times negative 2? Negative 4. 5 plus a negative 4? 1. 1 times negative 2? Negative 2. Negative 7 times negative 2? Or sorry, plus negative 2? Negative 9. So what's negative 9? That's my remainder. Then I work my way backwards. I'm going to let c be my constant, x squared. All right, just like I showed you on Friday, you're going to write your final answer the same way. Okay? So this is going to be 3x squared plus 2x plus 1. Does anyone remember how we do it when we have a remainder? Good. You still put it over what you would have used in long division. You still put it over that x plus 2. I'm sorry? Well, there sure is. Thank you. There should be a 1 right there. So tell me what that tells us. What is not a factor? Good. X plus 2 is not a factor. What else do we know? Good. Negative 2 is not a root. You guys seeing the difference between the two? Factors are like what you would put in your factored form if you factored it out. Root is when you would solve that for 0. All right, let's keep going. (6x cubed plus 5x squared minus 3x minus 2 divided by x plus 1. Am I allowed to use synthetic division? Yes. How do you know? Yeah, we've got linear. We have no coefficient in front of x. It's just x plus 1. All right, so what goes on the outside? Negative 1. My top row should read 6, 5, negative 3, negative 2. All right, give it a try. Does yours look like this? Yeah. What is that 0? My remainder. Then my constant, x, and x squared. So my answer is 6x squared minus x minus 2. Leah, you got a question? Got it? Okay. Questions? Okay, That's my answer, but I want to keep going with this, okay? A remainder of 0 gives me a lot of information, okay? It gives me a lot of good information that I can use, right? What if I was asked to factor? Good. What else is a factor? Good. Can 6x squared minus x minus 2 be factored further? Yeah, go ahead and take a moment and factor that real quick. Do you get 2x plus 1 times 3x minus 2? Is that factored as far as we can go? Yeah, everything is linear, so we're all good. Okay? So we have now factored. What does that tell me? What can I do now? Could I find my roots? Yeah, let's find our roots. How do we find roots of this? What do we do with each of those? Yeah, so for my roots, x plus 1, what root would that give me? Negative 1. 2x plus 1, what root will that give me? Negative 1/2. 3x minus 2, what root does that give me? 2/3. So what kind of roots are these? They're real. These are all real roots. So when I have real roots, what else are they if I wanted to maybe graph this? These are points that are, yeah, these are my x-intercepts. Real roots are always x-intercepts. So since this polynomial has 3 real roots, it means it also has 3 x-intercepts. All right? So if, yes?
Does that mean that it has like 2 switching points?
What do you mean by switching points?
On the graph? Does that mean it has...
Well, we're going to graph it, so go ahead and watch us as we graph it, and then if you still have your question, ask me again. Okay? So if I want to graph, let's think about a little bit, some other information that would help me. Okay? I know my x-intercept. Do I know my y-intercept? How could I find it? Sam? Yeah, I could plug in 0 for x in which polynomial? Yeah, back up here at my original one. 6x cubed plus 5x squared minus 3x minus 2. So if I plug in 0, what happens to all of these terms? They cancel, they go away, and all I'm left with is negative 2. So what's my y-intercept? Negative 2. All right, let's talk about our end behavior. Let's talk about what's going to happen to the right and what's going to happen to the left. What's going to happen to the right? No. It's not going to fall, so it has to rise. How do you know it's going to rise? Good. My leading coefficient up here is 6. Okay? I'm going to go ahead and rewrite this. I'm going to graph 6x cubed plus 5x squared minus 3x minus 2. My leading coefficient is 6, right? So if my leading coefficient is positive, what does it do to the right? Rises to the right. What's it going to do to the left? Which one is it? Rise or fall? Fall. How do we know? Good. My degree is odd, which means it's opposite. All right, so let's try and graph this. Again, this is still going to be a sketch, but it's going to be a better sketch than when we started graphing these things. So plot the points that we know. We have 0, -2 as my y-intercept. Then I have x-intercepts at -1, -1/2, and 2/3. What happens to the left? Falls. And what happens to the right? Rise. And then we just got to kind of figure out what happens in between. Okay? So I'm going to go up here and go down there. How do I know that I could have 2 turns in this? It's cubed, right? And so whatever our degree is, we can always have 1 fewer turn than that. So we have 2 maximum turns. Now, is this exactly what this graph looks like? No, but is it closer than what we would have drawn a couple days ago? Yeah, it's a lot closer. Leah, was your question answered? You still have it.
Yeah, I thought it was that it turned.
No, it always turns 1 less than the degree. So it's going to turn twice. Okay? All right, let's keep going. X to the 4th plus 7x cubed plus 7x squared minus 15 is going to be equal to x times x plus 3 times 2 more factors. And I want us to find the 2 missing factors. So I've told you that what 2 things are already factors? X and x plus 3. And how many more factors am I looking for? 2. Ideas.
You could combine x and x plus 3 and then divide those into the one on the left.
We could. Would we be able to use synthetic division, though? Not if we multiplied x and x plus 3, because then it would be x squared plus 3x. So yes, we could multiply and use long division. That's definitely an option. Leah?
I don't think we can do synthetic division anyway because we would have to plug in a 0 for the thing.
You could.
You can,
Uh-huh.
but like if you plug in a 0, everything multiplies.
But remember, you're multiplying and adding, so things keep changing. So that's another idea, is we could use synthetic division with 0. Haley? Use synthetic division with 0? Okay, you have another idea?
Yeah, you could divide by x on both sides and then do synthetic division.
Okay, so we know that x is a factor, right? By the way, the other ideas, good ideas. I'm just going to show you what I think might be the easiest way, okay? We already know x is a factor, and just by looking at this, don't you already see that x is a factor? Because x is a GCF, right? So let's go ahead and factor out Sorry, I lost my pen. Let's factor out x. So what would I have left here? Okay? So all I did here was I went ahead and factored out x. Now what do I know has to be a factor of this? X plus 3. So could we do synthetic division on this cubic with x plus 3? Yeah. So let's go ahead and do that. Now remember, I'm using these coefficients in here.
Would it be negative 3?
Yes, thank you. Good catch. Why is this negative 3? Yeah, it's x plus 3 is our factor, so if I set it equal to 0, it would be negative. All right, so negative 3, and then I've got 1, 7, 7, and 15. Goodness. Can you tell it's Monday? All right, bring down our 1. So I'm going to have 1. 1 times negative 3 is negative 3. 7 plus negative 3, 4. 4 times negative 3, negative 12. 7 plus negative 12, negative 5. Negative 5 times negative 3, 15. Negative 15 plus 15. 0. Now that better have happened, right? Because we already knew that negative 3 had to be a root. We already knew that. But now let's see what we know. This is our remainder. This is our constant. This is our x. And this is our x squared. So let's write this out. This is x squared plus 4x minus 5. What can I do now? Factor. I could just factor like normal, right? Go ahead and factor this and see if you can come up with our 2 missing factors. What'd you get? What were your signs again? Good. These are your 2 missing factors. Think so.
Okay, so that's why you have to pull up.
And it just makes it easier to do synthetic division with fewer terms because we lowered the power. All right, so if I wanted to write this out in completely factored form, what would I have? Okay, factored form is really helpful because what information does it give us about the graph? The roots. In factored form, we know the roots. How many roots is this quartic going to have? It's going to have 4. What are they? Yeah. 3 roots. What kinds of roots are these? They're real. These are real roots. So that means these are also my x-intercepts. Okay, if I want to graph, I also want to know my y-intercept. What's my y-intercept here? It is going to be 0. Think about it. If 0 is a root, then what does the y value have to be at x equals 0? It's got to be y equals 0 too. So if 0 is a root, your y-intercept has to be 0. Okay? But we could also get it just by plugging in 0 to that equation up there. And would that give me 0? Yeah. So there's my y-intercept. What's it going to do to the right? It's going to rise to the right. Because the number in front of x to the 4th would be a positive 1. What's it going to do to the left? It's going to rise left also. Why? Good. Even degree. So let's try and sketch a graph of this. That was awful. Let's try again. Yeah. Yeah, I'm a cheater. It's okay. Who just called me a cheater? Yeah. It's all right. I'm using my resources is what I like to call it. All right, so let's mark down our x-intercepts. 0, -3, -5, and 1. Y-intercept is also at 0. To the right, I rise. To the left, I also rise. Huh? Oh, whoops. Thanks. All right, and then we just got to kind of make up the stuff in the middle. This was a quartic, so we could have 3 turns. So 1. Oops. Oh, goodness. Okay. Now, is this exactly what it would look like? No, but it's closer than whatever we would have drawn before today. Questions? There will be a graphing question on your quiz, okay? When is that quiz? Wednesday. There we go. Today is Monday. Today is Monday the 10th. So Wednesday the 12th is our polynomial quiz, okay? And then on Thursday, what's due, since we're talking about stuff? AP 4.1. Okay, so there will be a graphing question on your quiz, so just remember the process we went through, right? We found the roots, we found the y-intercept. Hold on, we're not done. I know it sounds like we are, but we're not. Found the roots, found the y-intercepts, and thought about the end behavior, rising and falling. Okay, let's work one more. Is f of x equals x plus 3, oh no, sorry, given f of x equals x plus 3x squared minus 10x minus 24, I would first like to know if x plus 2 is a factor. Then I would like to know what the other factors are. So what would I do? Okay, so I could use synthetic division to with -2, okay? What, if I plugged into, what information would that tell me? Well, if I plug in -2, it'll tell me if it's a... Okay, good. And if we get it equal to 0, then it will be. But in order to find the other factors, what am I eventually going to have to do? I'm going to have to do some sort of division, right? Because I've got to get x plus 2 out of there. So let's go ahead and use synthetic division here. Okay, you could also do what Corey is saying. You could plug in f of negative 2 up here and see if it equals 0. But still, for the second part, you would have to go ahead and do synthetic division. So let's go ahead and do syndiv. Negative 2, 1, 3, negative 10, negative 24. Is x plus 2 a factor? Yes. Is negative 2 a root? Yes. So if I did f of negative 2, what would I get? 0. Good, because my remainder is 0. Haley? Just stretching? Okay. All right, so now I know that x plus 2 is a factor. I want to find the other factors now. How has synthetic division helped me in that process? Yeah, I know that this this cubic up here factors an x squared plus x minus 12 is one of those factors. So how could I find the other two factors now? What would I do with x squared plus x minus 12? You would factor that. And what do we get when we factor that? Almost? Yeah, x plus 4, x minus 3. These are the two missing factors. And if I wanted to write it all in factored form, then I would have x plus 2, x plus 4, x minus 3. Okay? And we could keep finding, we could use the roots, we could graph it, we could do all that. But we're not going to. Okay? All right. Your homework is on page 426. Give me just a moment and I'll pull it up for you. You've got about 15 minutes.